and the pulley will move the same speed, and then the rope here is moving the same speed, which means the object will be moving the same speed. So if you pull on the rope, and anything the rope is touching will be going the same speed.
Okay, that's cool.
Okay, so A, we'll get those all together. So we have M2G equals half MP. I'm going to do this all in one step, but basically you move them all together and you factor out the A.
Mm-hmm. Okay.
And then you do like you did on the last one, and you divide by whatever quantity you have right there. So 1/2 MP. Okay. So that's your acceleration.
That makes sense.
In this case. Now, and then all you have to do to find the tensions is plug them back into your equations here. So you take that and you put it in here for A and here for A.
So T2 is equal to M2 times 2M2G divided by MP plus M2 plus M1
So that's negative.
minus M2.
No, so this is M2G, right?
Right. Oh.
So G is still just 9.8. So it'll be M2G minus. So you can make that, yeah.
Okay. That's cool. And
Yep.
then T1 is equal to
Right here.
mass of 1 times 2 M2G divided by MP plus M2 plus M1. Okay.
So which rope has greater, or which side of the rope has greater tension in it?
T2.
Yep. Okay. And then it says check your answer by setting the mass of the pulley to 0.
If we set the mass of the pulley equal to 0, then we would still get a greater tension. Wait, no. We'd get we would get M2 squared G.
Let me think. So for your tensions, you set the mass of the pulley equal to 0. So then you'd have to do M1 times 2 M2G, so 2 M1 M2G. You to solve for it this way. Oh, it's 1/2 MP.
Mm-hmm. Oh.
Right, so it's M2G over 1/2 MP plus N2 plus M1.
Okay.
So M2G minus M2 squared G. If you set that equal to 0, so let's, I'm just gonna erase this for a second. So the acceleration is easy to check, right? If you set this equal to 0, then obviously your acceleration is M2G over M2 plus M1, which is what we got in the first place. But tensions, so tension 2 equals M2G minus M2 squared G over M1 plus M2. This is for mass of the pulley equals 0. M1, M2 over M1 plus M2. Right?
Mm-hmm.
Okay. So we'll have to multiply. Let me put this over here. So T1 equals M1 M2 over M1 plus M2. So you have to multiply this top and bottom, so you have M1 plus M2 times M2G all over M1 plus M2 minus M2 squared G all over M1 plus M2.
How did you get these numbers?
So you get a common denominator for these.
Oh.
Oh, this is M1 M2G. I think.
It is G.
Yeah. Okay, so this one is that. So now you have, on top you'll have M1 M2G plus M2 squared G minus M2 squared G all over M1 plus M2. These two cancel. So, sure enough, if you put the mass of the pulley is equal to 0, then your tensions will be equal to each other. And your acceleration is equal to what you solved for before.
Question. Why did you have M1 plus M2 times M2G?
So that was getting a common denominator. So in order to get the common denominator, you have to take this and multiply it by the top and bottom, right? So that's just getting the common denominator.
But because you're just adding T2 together to make it look like T1. Okay, I thought you were putting in T1 into T2, but you weren't.
No, so we're just multiplying by this. So M1 over plus M2 over M1 plus M2 is just 1. But that's the only way you can add it together so they can look like each other.
So my question is, we solved that T2 was mg minus ma. How did you get this big long equation? You just said it equal to 0, and then you solved what you needed to in order to. Okay, I see what you did there.
Oh wait, no. So
you took the tensions. We took the tensions that we found. We found T1 and T2 with the mass of the pulley. We said the mass of the pulley equal to 0, and then we took those numbers and changed them around to equal each other.
Right. So that shows that the tensions are equal to each other, but actually, it's still equal to what we solved for. What did we solve for the tension to be before?
Tension 1 is M1A.
And what was A?
All of the stuff that we found.
Yeah, so A was M2G over M1 plus M2.
No.
So when you expand it, it's the same. This is wrong now, but we proved that T2 is the same as T1, and T1 is the same as the tension we saw for before.
Makes sense.